What if we moved Earth into Mars' orbit? Earth would now be 1.5 times farther from the sun than it is today. That means our planet would receive much less sunlight. Average temperatures would drop below freezing, turning Earth into an ice-covered world. Crops would struggle, oceans would freeze at the edges, and life as we know it would face a massive challenge. On the bright side, a year would be almost twice as long, about 687 days. So Earth and Mars' orbit wouldn't be the same paradise we know today. It would be a frozen desert. What do you think? Could humanity survive there? What if Jupiter lost just a bit of speed, dropping from 13 kilometers per second to around 7 kilometers per second? In this simulation, Jupiter's orbit decays and begins spiraling toward the sun. It started to lose its moons, leaving just Io. It crosses the orbits of Mars, Earth, Venus, and even Mercury. As it gets closer, Jupiter heats up, starts losing its atmosphere, and becomes unstable. Surprisingly, the inner planets continue their orbits, but now they share space with a falling giant. One small slowdown, with solar system-wide consequences. Do you think we'll be able to survive this? Let me know in the comments section. What if Jupiter was between Venus and Earth? Here's what happens if we place Jupiter between Venus and Earth. At first, Earth keeps orbiting the sun, but Jupiter's massive gravity quickly pulls us off our normal path. Our orbit stretches outward, making Earth swing further from the sun. Over time, this shift would throw our seasons and climate into chaos. Freezing winters, scorching summers, and unstable weather patterns. And it wouldn't stop there. Venus, Earth, and Mars would all feel the pull. Eventually, the inner solar system would be torn apart, planets colliding or even being ejected into deep space. So placing Jupiter here doesn't just give us a giant neighbor, it rewrites the fate of the entire solar system. Don't forget to like, share, and subscribe for more cosmic ideas. Imagine all the gas giants packed into the inner asteroid belt. At first, Saturn is the first to get ejected, drifting away from the chaos. Soon after, Neptune wobbles inward, its orbit shifting dangerously close to Jupiter, almost colliding with the giant, but just skimming past. Jupiter itself stays locked in place, massive and steady, while Neptune continues wobbling closer to the sun. Then Uranus begins sliding into the asteroid belt, its orbit pulled deeper and deeper into the chaos. With 4 massive planets crammed so close, their gravity would tear the inner solar system apart. And what do you think would happen next in the near future? What if we instantly increase the sun's mass to 1.5 times its current size? Earth's orbit would collapse inwards, rushing past Venus as gravity strengthens dramatically. On Earth, the environment would spiral into chaos. Temperatures skyrocket, oceans boil, the atmosphere strips away, and the planet becomes unrecognizable. In the near future, the entire solar system reshuffles. Planets are pulled into tighter, faster orbits, collisions become inevitable, and stability is gone. Mercury, too close to survive, would be ripped apart and explode, marking the first casualty of this new unstable solar system. What if the sun turned blue and doubled its temperature? A blue sun means it's much hotter, around 20,000 to 30,000 degrees Celsius compared to our current 5,500 degrees Celsius. Earth? It doesn't survive for long. Oceans boil away, the atmosphere gets stripped off, and temperatures rise beyond 400 degrees Celsius. Life is wiped out instantly. Mercury? It's the first to go. In the simulation, the surface cracks open. Then it explodes under the pressure and solar force. The smallest planet, gone in seconds. And Venus? Already a hellish world, now it glows like a furnace. Its thick atmosphere turns into plasma, and the planet slowly vaporizes under the blue sun's rage. What should we try next? Drop your idea in the comments. Your simulation might be the next video. What if a brown dwarf appeared between Earth and Venus? At first, Earth would swing dangerously close to the brown dwarf, heating up as its gravity pulls our planet. Temperatures rise, oceans boil, and Earth's orbit spirals out of control. Next, Earth is flung out of the solar system entirely, adrift in the darkness of interstellar space. Mercury soon follows, torn from the sun and ejected into the void. Then Venus is next, ripped away by the dwarf star's gravity. Finally, only Mars remains. The red planet keeps circling the sun, the last survivor of the inner solar system. In this cosmic battle, Mars is the winner. What if we put a brown dwarf, a failed star, in Jupiter's orbit? A brown dwarf is much bigger and heavier than Jupiter, with intense gravity and heat. The moment it appears, its pull would disrupt the orbits of every planet in the solar system. Asteroids from the belt would get thrown everywhere. Saturn's orbit could shift wildly, maybe even sending it crashing inward. Earth's path around the sun might change, making our climate unstable, with freezing winters, scorching summers, and chaotic storms. Crops could fail, oceans could shift, and mass extinctions could follow. Its faint glow wouldn't replace the sun's warmth, but it would light up the night sky with a reddish hue. Moons near it would heat up from tidal forces, possibly becoming volcanic worlds like Io. But even more extreme, within thousands of years, the sun-brown dwarf tug-of-war could tear the solar system apart. So, let's just keep brown dwarfs in deep space, far away from home. What if a black hole appeared just outside the asteroid belt? In this simulation, I placed a black hole just outside the asteroid belt, locked in a binary system with the sun. The black hole's gravity immediately begins to disrupt the asteroid belt, tearing it apart. Some asteroids spiral into the sun, others are captured by the black hole, and many are thrown out of the solar system entirely. Earth feels the effects next. Its orbit starts to shift and wobble, while waves of redirected asteroids slam into the planet, causing devastating impact storms and long-term climate changes. Mars doesn't escape either. The planet's path is pulled slightly toward the black hole, making its orbit unstable over thousands of years. Over time, the sun-black hole binary rearranges the entire solar system. Some planets find themselves in new orbits, while others are ejected into the darkness of interstellar space. Tell me in the comments section what to do next. What if Titan orbited the sun where Earth is? Titan is massive for a moon, even bigger than Mercury. But it's no Earth. It's cold, covered in ice, and has lakes of methane. Titan's thick, hazy skies would start to shift as sunlight hits. Methane breaks down, and the haze clears up, making the atmosphere look brighter and denser at first. But here's the twist. Titan has no magnetic field, so over time, the sun's radiation would start stripping the atmosphere away, layer by layer. It begins with a glow and ends with silence. Subscribe for more simulation videos. What if humans actually built a Dyson sphere around the sun? A Dyson sphere is a megastructure that surrounds a star to capture its energy, like turning the sun into a power battery for an advanced civilization. But if we completely enclose the sun with a solid shell, Earth would be in big trouble. We'd lose all sunlight, no heat, no photosynthesis, no life. The planet would freeze solid in weeks. Worse, blocking the sun's gravity with a massive shell could destabilize planetary orbits. Earth might drift, collide with other planets, or be flung into deep space. So while a Dyson sphere sounds like sci-fi genius, it might just destroy the solar system in the process.